This is the ROS Developers Podcast, episode 39.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. Hi, this is Ricardo. This is Ricardo from The Construct, and today I would like to dedicate the podcast to all those ROS developers that bought a robot which doesn't run in ROS, and they would like to make it running in ROS. So how can you ROSify that robot? How can you make it work with ROS? Well, the interview of today may be very useful for you on that subject. We are going to interview Omri Ben-Bassat, who is from Tel Aviv and is a self-taught programmer, is a hacker, roboticist, enthusiast, and even since joining the first robotics competition team back in the high school, he has been working on robotics and learning about ROS in a general sense. So today he came here to the podcast to talk to us about a very cool project that he's been developing about ROSifying the vector robot. Welcome to the podcast, Omri.
Thank you, Ricardo. And hello, everyone. Great to be here.
Yes, our pleasure, of course. And let me ask you first, which kind of robot or which robot is this Anki robot?
The Anki robot is Vector Anki. It's a very cool, small, like home robot that you can just put on your desktop, and he walks around and he asks for attention, and you can play with him and do stuff in general.
Okay. Yes, and it's also quite cute in the sense of the movements and the expressions.
Yeah. It's really an amazing product. It feels kind of like a living creature.
Nice. Okay, nice. And then why did you decide to build the ROS packages for Vector robot?
Basically, I looked for a project to kind of a final project to summarize like a bunch of online courses that I did on ROS in Robot Ignite Academy, by the way.
Okay, nice.
Yeah.
I didn't know that. That's cool.
Yeah.
That's cool.
Great courses. I really learned a lot, and I felt that I need like more of a medium size project that I can do and kind of, practice writing topic publishers and services and actions and all of that. And I saw that Anki has no ROS package for Vector, so I decided to write one.
Okay. And one quick question is that you are mentioning the Vector robot of Anki, that is the latest version of a robot that is actually called Cosmo. Maybe the audience will know better the robot Cosmo because it's been already a while here, and this Vector is like a second version of Cosmo. Is that right?
Yeah, Vector is basically it's the same hardware, like in like the same shell, external shell, but Cosmo was more for like educational purposes, where you can program it with the graphical interface and do a lot of cool stuff. And Vector is like Cosmo, but with kind of his own personality. If you would put Cosmo on your desktop, it won't move until you'll tell him so. But if you put Vector on your desktop, is not gonna stop moving and playing around.
Okay, then it's more like, for example, do you remember that robot, Aibo from Sony?
Yeah.
There was a dog.
It's more it's more like Aibo.
Okay, but in a smaller size?
Yeah, smaller size, smaller price. They kind of wanted to do something that could fit every desktop.
That's nice. Yeah, so we can have it here while we are programming other
Yeah.
software. Nice. The second question is,
Yeah.
what functionality does your package provide to the vector robot? It has access to the camera, the wheels, the infrared.
Yeah, so the package, it doesn't cover everything yet. Now it provides like access to the wheels and driving and the camera through dedicated topics. And you can also access, like, use the move the head and move the lift using services. And you can also like say stuff through Vector. You have like a say service for that.
Okay, for playing.
Yeah,
For playing speech, I mean, for
yeah, like talking.
talking. Yeah.
For him. And there's something called animations in the SDK, which is like a kind of behaviors that are pre-programmed in Vector, like going back to his charger. So I also exposed these animations for action.
Wow, that's super cool. Then, so we actually could run like a complete new behavior system for the robot based on the basic behaviors that already provides the SDK.
Yes, yes.
Nice. And are you publishing also the TF of the robot?
Yeah, so I'm currently using like a third-party ROS package called the diff drive to manage the command vel and the ODOM publishing. So through that, I'm publishing like the transformation from the ODOM to the robot frame. But that's currently pretty much it. I also plan on adding like a full URDF for the robot that currently I don't have. And then I could also publish the joint states of the head and lift.
Okay, so yeah, so you are publishing the TF of the head and the lift. The TF is provided, but not the joint states.
Yeah, basically.
Is that correct? Okay,
Yeah,
okay.
that's correct.
I see. So what I mean is that I'm asking you that question because in case that, for example, your head is the head of the robot is moved, and then you use the camera is installed on the head of the robot, then you can know that it's been.
You can do the calculation and know like what's the angle when you take the picture, but currently I don't provide that.
Okay. So there is no transformation, no transformation between the base link of the robot and the camera.
Exactly.
Okay.
There's only the transformation between the base link and the world, basically.
And the
like
world. Okay, great. Then related to the URDF that you mentioned, maybe I can help you because we have created a simulation of the Cosmo robot. And then I can provide you that to you. So it's free, it's open source, so it's there. And so maybe you can use it and add to your package if you are interested.
Yeah, actually, I saw like I just started to watch the live course that you do with Cosmo. And,
the live class.
Yeah, and I saw that you got a URDF there, and that's actually a pretty good idea because I thought about like creating the mesh for the URDF by myself in SolidWorks and stuff. So that would probably take me like a lot of time.
Yeah.
But yeah, I could use, because it's the same external shell, then I could use your URDF.
Yeah. Exactly. So that's the idea that the external shell, as you mentioned before, is the same. And actually, we didn't create the construct. We didn't create the parts, the meshes. So the whole mesh was already provided by Anki, the company that builds. Yeah, they published this, but as a whole. Then what we did was to separate into the different pieces. The head, the wheels, the lift, all that. That's what we did. And then create the URDF. So I will provide you that later after the
Sounds good.
Interview. Okay, very good. Then, so now let's imagine that there is one person there that has bought the Vector robot and also has downloaded your packages from for ROS for Vector. Then how would it be the architecture? So how this person has to make it work? So where is running everything of every part of this whole architecture? Can you explain it?
Yeah, so that's actually an excellent question. And every time that I showed someone from work or from the local hackerspace this thing, then they were all pretty sure that it runs on Vector itself,
inside the robot.
Yeah, which is not. The node is actually designed to run externally on my local laptop. And in general, it's kind of like a wrapper of the Python SDK from Anki. So it kind of remote control everything from the node. There's like different levels of ROSification that you can do, but like the best would be probably to create some ROS firmware for the vector, the transzone vector itself. But that's not something that the company that Anki is giving us access to, sadly.
Yeah, that would be difficult, I think. And then what you mean is that then you run these your packages on the local computer, on your laptop, for example, and then this laptop is connected some way to the vector Anki. How is this connection made?
So you just need to be like on the same Wi-Fi network, and you need to and you basically use your Anki account with the Python SDK, and you can connect to your robot on your local Wi-Fi network from the laptop.
Okay. So this vector robot, it's connected to the Wi-Fi with an IP.
Yes, exactly.
And then you identify by the IP inside your local network.
Yes, and then it just like doing RPC calls on over IP. Yeah.
Okay. Yeah. Well, I'm asking you that because I know that on the previous version on Cosmo, it was quite complicated to connect from another computer because you have to do it through the mobile phone. And then I actually don't know how it works, but I heard that it was quite complicated. In this case, with Vector, that point has been simplified up to a IP over a Wi-Fi.
Yes. Like I don't know about Cosmo, but yeah, in Vector it's like that.
It's super simple. Okay, that's great. Then inside your computer, you can send the command. You use those services and actions that you mentioned you have actually built an application that the developers can run in order to test everything. What is that application that you built?
I built this red ball tracker.
Okay.
Where you can just put like a small spongy red ball. So Vector will see it, and once he sees it, he's gonna track it and rotate to keep it on the center of the picture.
Okay, it moves. It moves at a certain distance.
It doesn't move toward the ball. It just rotates.
Rotates. Okay.
Yeah.
Okay, great. Which version of ROS have you created these packages for Vector?
Melodic. So I could use like the most up-to-date packages.
And I read on the specification that it is required to use Python 3. No, but the default one in Melodic is Python 2. So why is that?
Yeah, that's true. It's basically because the Anki's Python SDK is really built specifically to Python 3.6.
Okay.
And they keep like modifying and improve the SDK, so I didn't want to mess with that. And I just like modified my ROS installation to work with Python 3.
Okay, but then that would be something difficult for the developers to do. So what can they do? Because if they have to modify the ROS installation also for working with Python 3, so what do you propose?
Yeah, so ROS was like it was designed to work with Python 2, and I really don't recommend using ROS 1 with Python 3.
Yes, me neither.
And I had a pretty rough experience with that. It took me a while to make it work, and I had more and more problems along the way. So in my GitHub repository, there's a Docker file with ROS melodic and everything that you need to have, so it would work as expected with Python 3.
Okay. So take it easy, developers. There is a solution. So Omri has created a very nice package and also a very nice way to test in your own computer. So don't worry. Very good.
And by the way, Ricardo, I also did like a blog post about that last week, explaining exactly how to set up your ROS 1 with Python 3 and the difficulties that I had.
Okay, so I'm going to copy that the link into the notes of the program of this podcast, and I will put it below so people that is interested on following the same pain that you have followed, then they can get less pain by reading your article.
Yeah.
That's great.
Yes, that's great.
Very good. And then explain us a little bit about the Vector Python SDK, because that's another requirement. So if you are planning to get your vector robot running with ROS, you are going to need the Python SDK. What is the purpose of this SDK?
So the purpose basically gives you almost full control of every vector functionality remotely for RPC that they wrapped. And you can just like create a vector object with your Anki account and vector's IP, and you're connected, and you can do everything through simple Python. Okay.
That I'm asking you that because there are different levels of developers, and then some of them will not. They will just think that they can connect directly from ROS, but it's not to the robot. But it's not true. From a ROS node, I mean. So you are using the Vector SDK for connecting to the robot itself.
Yes, exactly.
And then you create a node in Python, and a node in ROS node in Python that uses this SDK to connect to the robot. That's a process.
Exactly. So if you'll take, for example, getting the image from the camera, okay? So from the vector SDK, you get kind of a pill or pillow image. And for that to work with ROS, you want to convert it into the correct format. And after that, you want to publish it somehow. So that's what the package is doing.
Yeah. Okay. So now it's very clear the internal pipe of working of your package. Great. And then let me see another question. One question, but I think that you already explained that your package is only targeting at present the vector robot, but it's not. You haven't tried with the Cosmo one.
No, I didn't. I just don't have a way to test it because I don't have a Cosmo.
Okay, so listeners that you are listening here, if you have a Cosmo and you would like to do this test, please can you do it, and then you can report to Omri in case that you have any problem or maybe a success, so he can know that there has been a success implementation in Cosmo. I will leave the details for contacting you, Omri, on beneath the notes of the podcast. Great. Okay. And then one question is about your opinion. So what was the most difficult part on the ROSification of Vector?
I think that the most difficult part was for sure working with Python 3 over ROS 1. But the process itself was like, it wasn't one difficulty, but it was a great learning experience to kind of design and decide where to use what. Like that should be at service, that should be an action, that should be a topic, and all of that.
Oh, that's nice. And do you have any plan to improve your project? Like, for example, apart from adding access to other sensors like the IMU or the infrared, or also to port into ROS2?
Yeah, so I have plans to. I'm waiting for Anki to add the audio support in their SDK. So you could also like add actual commands when you say hey vector to vector, and then get the audio and do like
Speech processing?
Speech to text. Yeah, text speech processing, and then like do extra stuff. That could be cool. And yes, I'm also planning on porting it to ROS2 when I learn and be confident in writing ROS2 packages.
Okay.
So that could be also a great project for that.
Exactly. That's the next step. Exactly. You have learned about ROS1, then you have done the project on Vector with ROS1. Now you learn about ROS2, and then that's nice. That would be nice. Please let us know if you do it, and then we can do another review here, and maybe you can share the differences between porting to ROS1, ROS2.
Yeah, that could be really good.
Yes, exactly. So whenever you have it, let us know, and we'll bring you back to the podcast.
That's cool.
Great. And you mentioned that your package is unofficial. So it's an official package of Vector. That means that you are not related in any way with the company Anki from the creator of the robot. But do you have any contact with them, or any way that you have provided to them the package for their evaluation, or any feedback from them?
No, so I actually didn't think about it. I kind of just looked around and I saw that there is no package like that, and decided to do it and done it. But I think that I will try to talk with them and see like what's their opinion about it.
Okay, I read some messages on the Vector, Anki company. There is a forum, kind of forum.
Yeah, the developer forum.
Yeah, the developer forum, and there were some people there asking about support for ROS, for the robot, for the Cosmo robot, and they were saying that they started at some point to do it, but then finally they abandoned that because they wanted to concentrate on their SDK. So maybe your proposal will come at a good moment where they are thinking about putting ROS, and then you provide already this. So I don't know. Maybe there's business there. I don't know. Yes. Just leave it. The idea is there. I hope that you do a lot of business with that.
That's a good idea.
Yeah. And okay, so then we are going to end here with the interview. But before we finish, let me tell you that I was thinking myself to buy one Vector robot. Would you recommend it?
For sure, I recommend it. It's an amazing product, and I took it to my office and put it on my desktop, and I think that everyone in the office just fell in love in the robot.
Okay, that is great. Let me remind you to the listeners that we have no relation with Anki.
It's not a commercial.
No, it's not a commercial, so we haven't. No, but it's really cool that's why we decided to create this live class series about programming that robot, because we also thought that was cool. The problem is that we did on simulation only and not on the real one. Maybe we can do a test with the real one, because on our system we can connect to a real robot, to a real Cosmo robot.
Yes.
Directly, but we didn't have a real vector, I would say. Then maybe we can do an experiment and connect our software to your robot in your location. I mean,
let's do it.
Yeah, we do that. Interesting. So okay. So let's talk after the podcast interview. Yeah, and let's see if we can do it. Okay, so that is all from my side, and thank you very much for coming here, and thank you for dedicating to to create those packages. So interesting, that really show how to apply ROS to a non-ROS robot. That's a very good example. Thank you very much, Omri.
Thank you, Ricardo. It was great talking to you.
Okay, and for all the listeners, remember that if you want to learn ROS fast, then there is no better place than the Robot Ignite Academy. Omri already said, and we didn't have any relation or commercial relation in any kind. But the Robot Ignite Academy, you will learn ROS online, practicing in an integrated web environment that contains the lessons, the simulators, the code development tools, everything integrated inside a web browser. It doesn't require any installation from your site. It's really the fastest method to learn ROS. And also you can learn other related subjects like ROS for autonomous cars, ROS for industrial robots, or machine learning applied to robotics, everything related to ROS, okay? So have a look at the following address, very simple, robotignite.academy. And that is all for today. Thank you very much for listening, and see you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.
The ROS developers podcast. The ROS developers. The ROS developers podcast. The ROS developers. The ROS developers podcast. The ROS developers.